Hi, this is Krishna. In this video, I'm going to demonstrate the Xtoon shading. Xtoon is an extended toon shader which is introduced with two extensions for the basic toon shader. It is used to support the view-dependent effects. The two extensions are the tone detail and the shape detail. We concentrate on the tone detail part for this assignment. In tone detail, the traditional 1D texture is replaced by a 2D texture in which the vertical axis denotes the detail and the horizontal axis denotes the tone. To control the tone, we use different attribute mapping. Few of them are depth, attribute, and orientation. So, based on the depth, the detail value may vary, and based on the orientation, the detail value varies. So, to implement that, in this assignment, we have shown 4 different shaders: depth shader, focus shader, near silhouette shader, and the font highlight shader. So the depth shader and the focus shader will come under the depth based attribute mapping, and the near silhouette shader and the font highlight shader will come under the orientation based attribute mapping. So based on the depth and orientation, we can control the detail of the shading. So this is the IMGUI interface that I implemented. So here we can select any shader and we can select any model. So these are the different models that I have in my scene. So, and also we can select different textures, and we can see the selected texture here, and we can change the light position. We can have some controls to the shader, and we can change the model position, and we can change the model angle. So first, going to the depth based attribute mapping. So here I'm using a depth shader, and I'm using the teapot model only for demonstration purpose today. So now if I change the light angle and if I change the Z-min value, angle, now as the object moves far, we can see the difference. So here we are using a blurred texture. This smooths out based on the distance. So as the depth increases, the detail varies. This is an example of depth based attribute mapping. So another example texture that I'm using here is this. So if I move along the z-axis, we can see the difference in the shading. So this shows the discrete level of abstraction in the scene, and this is another model, another texture. So if I move it, we can see after a particular distance there is a difference in the shading. So this is mostly giving us the shadow effect. So this is the texture that is used for this. Next, now going to focus based attribute mapping, I'm using a focus texture and the focus shader. I can change the Z focus value to see the difference. And also I can move this alongside axis to see the difference. This texture is used to focus on a particular region of an object. Next, we are enabling the near silhouette shader. So, and I'm using the first texture for this. Okay, this texture, we can observe here that this part of the object does not have any hard boundaries, and this part of the object has some hard boundaries. So to generate effects like this, we use this near silhouette shader and textures like this. So in this texture, the intermediate tones are blurred before the darker tones. So this removes the hard boundaries, the areas that are not facing the camera directly. So, and I can also increase the R value to increase or decrease the magnitude of the effect. And this is orientation based mapping. So now I'm going to change the texture. This is one of the texture that we are using. So using this we can generate effects like fading of the near silhouette regions. So we can see that the silhouette regions got faded, and also now I'm going to change the texture again. So this time we're using texture like this. So the use of this texture is to generate a cool effect like backlighting. So let us see. If I increase the R value, we can see that the object has some backlighting effect here. So the position of the light and the position of the object and the orientation of the object will decide the magnitude of the effect, and even the R value that we are using. So this is all about the near silhouette shader, and then the last one is the highlight thing, which also is included in the view dependent effect. So we are using Phong highlight shader here. So now if I change the Z value, and also the shininess coefficient is used to control the effect, magnitude of the effect. So using this texture makes the object look like plastic in combination with the Phong highlight shader. Now I can also change this to another texture. This is a metallic texture. So this makes the object look like metal. So you can also change the orientation of the object to see the effects. as this comes under the orientation based attribute mapping. We can see the changing of the effects based on the orientation. This is another texture use. So this makes the object reader along the boundaries